Before doing operations on complex numbers, let's review complex numbers in general. In the number system, we have natural numbers. These are numbers we naturally use for counting, like 1, 2, 3, etc. Whole numbers are the natural numbers plus the number 0. Integers are the whole numbers and their opposites, their negatives. So integers are 0, 1, 2, 3, etc., as well as -1, -2, -3, etc. Rational numbers are numbers that can be written as ratios or fractions. If a number is not rational, we say that that number is irrational. A few examples of irrational numbers will be decimal numbers that have no repeating pattern, the number pi, or the natural number e. All of these numbers are real. We also have non-real numbers that we call imaginary numbers. These numbers have the imaginary unit I attached to them, and the imaginary unit I is defined as the square root of -1. Complex numbers are numbers that involve both the real and the imaginary numbers and are written in the form of a plus bi. Let's talk a little bit about writing complex numbers. Any number we write, such as the number 3, is a complex number, where the imaginary part, b, is equal to 0. So 3 is also 3 plus 0i in complex form. The other special situation would be the pure imaginary number of 4i, which is the complex number of 0 plus 4i. Combining these two numbers, we would have the complex number of 3 plus 4i. One more note I want to mention is what I call the parade of pretty numbers. Let's write some examples of numbers and terms, such as 5xy and 3x the square root of 7. If these numbers were imaginary, I would write 5xyi and 3xi the square root of 7. Notice that we write letters in alphabetical order except when we have the imaginary unit I. We treat I as a radical number, and we write radical numbers at the end, but we write I before the actual radical sign. This is why I call this the parade of pretty numbers. The pretty integer numbers go in the front, variables in the imaginary unit I go in the middle, and the radical number goes at the end.